When Neil Armstrong's boot pressed softly into the powder-grey dust, the world seemed to hold its breath. The hum of mission control, the faint static of radio transmissions, even the slow beating of hearts watching from millions of miles away, everything quieted. The moon, that ancient and distant companion, had been touched by life for the first time. The silence that followed was not empty. It was vast, alive with the echo of history being rewritten in the gentlest possible way. That quiet became the sound of wonder itself. The dust stirred by his step hung in the still lunar air, moving slower than any motion on Earth. There was no wind to scatter it, no sound to announce it. Each tiny grain settled as if deciding where eternity would hold it next. It was a silence deeper than oceans, more endless than sky, a silence that wrapped around the astronauts like an invisible blanket. They were standing where no human senses had ever been awake before, on a world untouched by breath, by wind, by rain. The horizon stretched small and curved, making the moon feel both close and infinite at once. Armstrong looked toward it, his visor catching the pale reflection of Earth floating in blackness. That small blue sphere shimmered in the distance, silent and fragile, a glowing marble of home. He could see everything and nothing, every life he'd ever known compressed into that distant sphere. It was a sight that filled him with both pride and the strange ache of being so impossibly far from it. Buzz Aldrin joined him, and the two stood together, their voices soft, almost reverent, carried only through radio. They spoke little, because words felt too small. Every movement was careful, ritualistic, the planting of the flag, the unfolding of instruments, the soft bounce of lunar gravity under their boots. It wasn't just exploration, it was communion. The surface beneath them was ancient, older than the oldest rocks on Earth. They were visitors on sacred ground. In Houston, the controllers watched their screens with tears and tension mixed together. For them, it was numbers, readings, signals. But even through the math, they felt the weight of that moment pressing through the static. The moon's quiet presence filled the control room in spirit. Those watching at home could feel it too, a strange, enveloping calm. As though, for a few heartbeats, humanity itself had stepped outside of time. The moon's surface seemed gentle, but it told silent stories of violence. Craters stretched endlessly, carved by collisions that had shaped the solar system. Each dent was a memory, a record of chaos written in dust and rock. Yet here it lay, still and patient, waiting billions of years for a single step to mark a new kind of impact, not from a meteor, but from a mind. The first step of thought upon ancient matter. As Armstrong moved, he noticed how light behaved differently here. Shadows were sharp and absolute, brightness was blinding and pure. The sun's unfiltered rays painted the landscape in high contrast, a world of extremes, black or white, nothing between. Even time seemed strange, stretched thin in this eternal day. It was as if reality itself moved slower, lulled by the absence of sound. The moon was not just silent, it was timeless. They collected rocks, small grey fragments that looked unremarkable but carried billions of years of history. Each one was a messenger from an era before life, before seas, before memory. To hold one was to touch the beginning of worlds. And yet, these fragments would travel back home, where scientists would whisper over them in awe, searching for the secrets hidden in their silent cores. The moon had waited so long to tell its story. The footprints they left were shallow, crisp, unchanging. With no wind to erase them, they would remain for centuries, perhaps longer than any monument on Earth. Each print was a frozen whisper of movement, a delicate scar of humanity's reach. Someday, long after the voices that made them had faded, those impressions would still speak softly of the night humans first met another world. Aldrin looked toward the horizon and described the view as magnificent desolation. The words captured the moon perfectly, a place of emptiness that was also full of quiet meaning. The stillness here was not cold but profound. It was the stillness of creation paused mid-breath, holding a secret too deep for words. The moon wasn't lonely, it was simply waiting to be understood. As they explored, every step felt like trespassing on eternity. The dust, untouched for eons, shifted beneath their boots, creating small clouds that floated lazily before settling back down. It was mesmerizing to watch how slowly everything moved. Even the motion of their hands seemed like underwater gestures, gentle and deliberate. The moon demanded respect through its silence. Inside their suits, the astronauts could hear only their own breathing, rhythmic and human. That sound, air moving, lungs expanding, became a fragile reminder that they did not belong here. Each breath was a heartbeat against the vacuum, a rhythm of life inside a sea of nothingness. It was both reassuring and haunting, like hearing your pulse in a cathedral built by stars. As minutes turned to hours, the mission unfolded with practiced grace. They deployed experiments, collected data, and moved according to plan. But between the tasks, there were quiet moments when the grandeur of what they had done crept in. Those moments were private, too big to share. The moon, indifferent yet embracing, seemed to listen without judgment. Armstrong once turned to look at the Earth again. Its blue shimmer had a faint glow against the black void, and for a fleeting second, he imagined he could hear it, like the memory of laughter, rain, and wind carried across emptiness. That vision, that tiny glowing world, reminded him of everything fragile about existence. The moon was proof of endurance, Earth was proof of life. When it was time to return, their departure felt both necessary and reluctant. The ladder back to the lunar module gleamed faintly in the unfiltered sunlight. Each step upward was heavy with realization they had been to another world, but they could not stay. The moon would remain as it was, silent and unchanged, its new guests leaving only traces of their brief presence. As the lunar module lifted, dust rose in slow, curling waves, drifting like smoke that would never vanish. The engine's hum was swallowed by vacuum, leaving nothing behind but the quiet shimmer of footprints and a flag that stood perfectly still. The moon absorbed their leaving the way it had absorbed everything else, without sound, without protest. Just stillness. Back inside the module, they looked through small windows at the shrinking surface. The view was hauntingly beautiful, a soft grey world illuminated by the sunlight of eternity. They knew that humanity would return, that this was not the end but the first whisper of a long conversation with the cosmos. Yet, for now, the moon receded into silence once more. As they broke orbit and began their journey home, the astronauts felt the weight of what they carried, not just rocks and samples, but perspective. They had seen Earth from a distance, fragile and bright, surrounded by the infinite quiet of space. It made every problem, every noise, every fear seem small and temporary. From that distance, everything human looked precious. The journey back through the void was slow, calm, and filled with reflection. Stars burned cold outside their window, unblinking, eternal. The spacecraft itself felt alive, like a small shell protecting them against infinity. In those silent hours, the moon became a memory already softening, turning into dreamlike whispers of grey horizons and distant shadows. When they finally saw Earth growing larger in the window, there was relief, but also a kind of loss. The moon had given them something intangible, a sense of perspective that could never be fully explained. They had touched stillness, breathed within silence, and brought a piece of it back with them. That silence, once alien, now lived quietly inside them. And as the world celebrated below, the moon remained unchanged. The footprints still lay there, shadows frozen in time. The flag still stood, unmoving. The quiet after the first footfall continued, undisturbed, echoing through eternity, a reminder that sometimes, the greatest discoveries speak not through sound or spectacle, but through silence itself. After Apollo 11, the moon no longer seemed unreachable. What once felt like a dream beyond imagination now felt like a destination, a quiet world that humanity could return to, study, and slowly understand. NASA planned more journeys, each one more ambitious than the last. These missions were not just about footsteps, they were about listening to what the moon had to say, piece by piece, through the rocks it offered and the mysteries it held beneath its dust-gray skin. Apollo 12 came next, guided by precision and purpose. The astronauts landed closer to a pre-selected target, near the Surveyor 3 probe that had touched down years earlier. This time, every move was more confident, every sample more deliberate. They wanted to see how the lunar surface affected human-made materials, to learn how the harsh sunlight and cosmic dust shaped everything it touched. Even in silence, the moon spoke through its scars, its textures, its quiet endurance. The soil the astronauts collected looked simple, grey powder, scattered rocks, but when examined back on Earth, it told stories older than continents. Some grains were glassy, formed by meteor impacts that melted the surface in brief flashes of unimaginable heat. Others were ancient, older than any earthly rock, fragments of the moon's crust from when it first formed. Each one held whispers of a time before time, when the young solar system was still finding its rhythm. Apollo 14, Apollo 15. Apollo 16, each mission deepened the human connection with the moon. They explored valleys, highlands, and vast plains of basalt frozen from once molten seas. Scientists studied the samples, searching for the moon's origin story. Some thought it was captured by Earth's gravity long ago. Others believed it formed alongside Earth, twin worlds born together. But as evidence grew, another theory began to take shape, one both dramatic and elegant. That theory was the giant impact hypothesis. It proposed that long ago, a massive object struck the young Earth, ejecting molten rock into orbit. That debris gathered and cooled, forming the moon. When scientists looked at the Apollo samples, the chemistry supported it. Lunar rocks were strikingly similar to Earth's mantle, yet slightly different, like siblings separated at birth. It was as if the moon was made from Earth's own memory, orbiting forever as a reminder of that ancient collision. Apollo 15 brought a new level of exploration, the Lunar Roving Vehicle, a small electric car that allowed astronauts to travel farther than ever before. With it, they explored mountains and craters miles apart, collecting samples from diverse regions. The dust clung stubbornly to everything, coating their suits, tools, and rover in a fine grey layer. It was soft to the eye but sharp under the microscope, like tiny shards of glass, shaped by eons of micrometeorite impacts. The samples from Apollo 15 included a special rock later nicknamed the Genesis Rock. It was a piece of the moon's original crust, over 4 billion years old. Holding it was like holding the dawn of the solar system, a fragment from the very first solid surface that formed around our sun. When scientists examined it, they saw in its minerals a record of cosmic birth, frozen and preserved in the moon's silence. Apollo 16 and 17 carried the torch even farther. They explored the rugged lunar highlands, where ancient impacts had exposed deep layers of crust. The astronauts collected more than just rocks, they gathered clues about how the moon evolved, how its early oceans of molten rock cooled, and how the constant bombardment of meteorites had sculpted its surface. Each mission added new chapters to a story written not in words, but in stone and dust. In total, the Apollo program brought back 382 kilograms of lunar material. Those samples became treasures of science, studied for decades in laboratories around the world. Under microscopes, they revealed a world without weather, without erosion, where even the tiniest scratches from space dust remained for eternity. They became time capsules, preserving cosmic history in a way Earth's restless geology never could. The samples also told a more personal story of how fragile exploration really is. Each grain had to be handled with care, stored in nitrogen chambers to prevent contamination. Scientists realized that these simple rocks were irreplaceable. No machine or telescope could ever tell them what a human hand could learn from holding them. The moon had been generous, but also finite. It offered pieces of itself only through effort and respect. As technology improved, the analysis of those samples grew more precise. Decades later, instruments could detect isotopes and elements that earlier tools missed. These discoveries continued to refine the moon's story, showing that volcanic activity had once reshaped parts of its surface and that water, though scarce, might still hide within its minerals. The moon was not as dead as once thought. It still whispered of ancient movement and unseen transformation. Each mission also changed how humans saw themselves. To touch another world, to bring pieces of it home, was to stretch imagination beyond the limits of sky. Every astronaut who returned from the moon spoke of perspective, how small Earth looked, how fragile it felt. That sense of humility seeped into the stones themselves, quiet reminders of how far curiosity could take us, and how delicate life was in the face of cosmic vastness. When Apollo 17 lifted off in 1972, it carried not only samples but the last footsteps of the century's greatest adventure. Commander Eugene Cernan turned toward the horizon one last time, promising that humanity would return. As the lunar module rose, the dust swirled once more, silent and slow, and the moon returned to its waiting stillness. The story of Apollo ended, but its echoes continued through science, art, and dreams. In laboratories, scientists worked in near silence, studying the rocks as though decoding messages from an ancient civilization. Every mineral layer, every microscopic bubble, revealed how the moon cooled and solidified, how its magnetic field faded, and how impacts had written their own chaotic poetry across its face. These stones were not just cold relics, they were storytellers, whispering across billions of years. The moon, it turned out, was more complex than expected. Beneath its dusty crust lay clues of hidden depth, a layered structure, perhaps once molten, now frozen. Some samples hinted at faint traces of volcanic glass, showing that lava once flowed in ancient times. Others revealed impact melt, a fusion of stone and fire created by collisions so fierce they blurred the line between destruction and creation. Even the dust itself fascinated scientists. Its texture, its sharpness, its electrostatic cling, it behaved unlike anything on Earth. It revealed how, in the absence of air and water, the smallest particles could retain strange electrical charges from sunlight. Astronauts had struggled with it sticking to everything, yet it also became a key to understanding how the moon's surface interacts with solar radiation. With every discovery came a quiet truth: the moon was not just a barren rock. It was a living record of cosmic evolution, untouched by time. It preserved the scars and triumphs of creation itself, an archive of everything that had ever touched it, from asteroid impacts to human footprints. Its silence was not emptiness but patience, waiting for minds ready to listen. As scientists continued their work, they began to dream again. The Apollo samples showed that the moon was rich not only in knowledge but in possibility. Minerals and resources, frozen water in shadowed craters, and stable ground for future bases, it all painted a picture of a new frontier waiting to be revisited. The samples became both relics of the past and blueprints for the future. Over time, new missions began to orbit the moon again. Robotic probes mapped its surface in exquisite detail, searching for the perfect landing sites of tomorrow. Yet even as machines returned, the spirit of Apollo lingered. The samples that lay locked in labs reminded everyone that true discovery requires human presence, the touch of hands, the rhythm of breathing, the feeling of dust beneath boots. The moon waited, unchanged and eternal, but no longer alone. It had shared its story once, through those precious stones, and it knew humanity would listen again someday. The samples continued to glow faintly under laboratory lights, their ancient crystals holding the reflection of the first explorers who had dared to touch them. Each one was a quiet promise that the story was not over. And so, the tale of more missions, more samples became more than a record of science, it became a testament to curiosity itself. For every rock collected, for every step taken, humanity had also gathered perspective, humility, and hope. The moon, once silent, had spoken. And in its stillness, it reminded us that knowledge is not just found, it is earned, patiently, respectfully, one footprint at a time. The moon's rocks were not just stones, they were storytellers, frozen narrators from a time when the solar system was young and wild. Each fragment carried within it the memory of violent creation, of molten seas hardening under strange sunlight, of endless silence settling upon cooling stone. When the Apollo astronauts brought them home, scientists realized they weren't holding mere minerals, they were cradling time itself, the oldest pages of a cosmic diary. When geologists first examined the samples, they were astonished by their age. Some rocks were over 4.4 billion years old, older than nearly anything found on Earth. Our planet's restless surface, churning oceans, shifting continents, and constant erosion had erased most of its early record. But the moon, lacking air and water, had kept its secret safe. The stones were pristine memories, untouched and unwavering, holding the history of creation in their quiet weight. The first types of rocks identified were basalts, born of ancient lunar lava flows. These came from the dark plains visible from Earth, called Maria, Latin four seas. They were formed when molten rock from deep within the moon welled up and cooled on the surface billions of years ago. Under microscopes, they revealed tiny crystals of olivine and pyroxene, minerals forged in heat and solidified in stillness. Each crystal shimmered faintly, a remnant of an ocean of fire. Then there were anorthosites, the gleaming white stones from the moon's highlands. These were even older, remnants of a time when the moon's entire surface may have been covered in a molten ocean. As it cooled, lighter minerals floated to the top, solidifying into the pale crust we see today. To hold an anorthosite was to touch the moon's very first skin, the layer upon which every crater, every shadow, every dream had since fallen. Impact breccias were another kind, rocks created not by calm formation but by sudden violence. When meteors struck the moon, their force shattered the surface, fusing broken fragments together under immense heat and pressure. These rocks were mosaics of destruction and rebirth, pieces of many stones melted and rebonded into one. They were evidence that creation and catastrophe had always been intertwined, even in the quietest corners of space. Among these samples were glass beads, tiny, colorful spheres scattered in the soil. Under Earth's light, they sparkled faintly, each one formed when molten droplets were thrown into the sky by ancient volcanic eruptions or impacts, then cooled rapidly as they fell. Some were green, some orange, some nearly black. These beads were the frozen tears of the moon, each one a miniature story of heat, flight, and silence. When scientists analyzed the chemistry of these rocks, they found something unexpected. Though similar to Earth's mantle, the lunar samples lacked volatile elements, things like water, carbon, and nitrogen. This absence told a deeper truth. The moon had been born in fire so intense that lighter materials had evaporated away. It was a world forged from Earth's molten heart, yet stripped bare by its own violent beginning. Each isotope ratio, each mineral grain, became a clue. They revealed that the moon's surface had once been reshaped by massive impacts, that its crust had floated atop a deep, molten ocean, and that volcanic activity had once bubbled beneath its surface before slowly fading. The moon had lived a full, tumultuous life before falling into its long slumber. These rocks were its dreams turned solid, fragments of that ancient memory. Scientists found that some rocks contained minute traces of magnetism. This was astonishing, because the moon today has no global magnetic field. It meant that billions of years ago, The moon might have possessed a molten core, swirling and alive, generating magnetism just as Earth's core does now. That discovery transformed the image of the moon from a static relic to a once-living, dynamic world. The Apollo samples also revealed a delicate balance between chaos and calm. Some surfaces were shattered and burned, while others remained untouched for eons. Micrometeorites had peppered the moon's face for billions of years, turning its soil into a fine, powdery regolith. That dust held stories of constant bombardment, of time measured not by wind or rain, but by impact after impact under a sky without sound. Every sample brought something new to light. Some contained volcanic glass formed in low-gravity eruptions, proving that the moon once belched fire from its depths. Others showed traces of cosmic rays embedded within them, recording the history of the sun's radiation. The moon's surface was like a giant memory card, capturing the tale of solar storms, cosmic winds, and the relentless passage of time in ways Earth never could. Through these rocks, humanity began to understand not only the moon's past but the solar systems as well. The craters, the basalts, the anorthosites, they were all chapters of a larger story that reached beyond the moon itself. By studying them, scientists could glimpse how planets formed, how worlds collided, and how cosmic debris shaped everything from Mercury to Mars. The moon was a mirror, reflecting the birth of all worlds. One of the most haunting discoveries came from the realization that the moon had been geologically dead for billions of years. Its volcanic heart had cooled, its surface frozen in eternal quiet. But in that stillness, it preserved what Earth had lost. The moon became a time capsule, a museum of cosmic history untouched by life's restless hands. Its rocks were fossils not of creatures, but of creation itself. Each new technique, mass spectrometry, electron microscopy, X-ray diffraction, unlocked new secrets from these ancient stones. Scientists could read in them the slow cooling rates of lava, the ages of impact events, the chemical fingerprints of early planetary differentiation. It was like decoding a long-forgotten language, one written in crystal lattices and isotope signatures, whispered through eons of stillness. Sometimes, under laboratory light, a sample would glint just so, and for a fleeting moment, a scientist might feel the same wonder the astronauts had felt standing beneath the lunar sky. Those rocks, once bathed in alien sunlight, now sat on earthly tables, bridging two worlds through the simple act of study. They were relics of exploration but also companions of curiosity, waiting patiently for human understanding to catch up to their age. As years passed, even unopened Apollo samples were revisited with new technology. NASA had sealed certain containers for future generations, knowing that science itself would evolve. When some of these were finally opened decades later, they yielded volatile gases and organic traces that earlier instruments could never have detected. The moon still had new stories to tell, even half a century after the first step was taken. In their quiet way, these rocks reminded humanity of continuity, that knowledge doesn't age, it deepens. The same stones that once rested untouched beneath alien skies now inspired new missions, new technologies, and new dreams. They whispered to engineers designing lunar bases, to children looking through telescopes, to poets who saw in them the reflection of timelessness itself. The moon's rocks also carried emotional gravity. Astronauts who had picked them up often spoke of feeling reverence, as though they were holding something sacred. On a world without life, without water or sound, these stones were the only witnesses. They had seen stars form and die, meteors strike, and sunlight change over billions of years. They were silent witnesses to everything. In museums and research centers, these samples now rest under glass, protected, revered, studied. Visitors who look upon them often feel something they cannot name. It is not just curiosity, but connection. Those grey fragments once lay beneath the boots of explorers, beneath a sky so black that Earth itself glowed like a lantern. They are reminders that our story is written not only in soil and air, but in the stars above. And though they cannot speak, their message is clear: the universe remembers. Every atom, every crystal, holds memory. The moon's rocks tell us that even in silence, the cosmos is full of narrative stories of formation, transformation, endurance. They teach that creation is not sudden but patient, that even chaos leaves patterns of beauty behind. The more humanity learns from them, the more profound their simplicity becomes. Each rock is a paradox, so small, yet infinite, so silent, yet eloquent. They teach that discovery is not always about newness, but about listening deeply to what already exists. The moon has been whispering for billions of years. The rocks are merely the echoes we finally learned to hear. And in their grey stillness lies a soft reminder that everything we are, every world we see, was once molten, chaotic, and uncertain. Yet out of that chaos came structure, and from silence came meaning. The moon's stones carry that truth within them, and in doing so, they remind us every story worth telling begins with a single grain of dust and the quiet patience of time. The moon's surface is not just a landscape, it is a memory, an endless record written in dust and stone. Every ridge, every crater, every shallow depression tells a story that stretches across billions of years. Unlike Earth, where wind and rain erase history, the moon keeps its scars. Its face is a book of impact and stillness, each mark preserved like a photograph that never fades. To walk upon it is to tread on the very handwriting of time itself. Because the moon has no atmosphere, its surface never changes except through the slow fall of meteors. There are no storms to smooth its craters, no water to fill its valleys. The same footprints left by the Apollo astronauts still rest where they were pressed decades ago, unspoiled by age. That permanence makes the moon a perfect archivist. Every grain of dust lies almost exactly where it has been for millions of years, holding the quiet record of cosmic history. Under sunlight, the regolith, the blanket of lunar soil, looks like fine ash, soft and unthreatening. But under magnification, it reveals its true nature: sharp, angular, unweathered. It is made of tiny fragments shattered by constant bombardment, each one with edges that could cut through cloth or rubber. Every fragment was born from impact, shaped by collisions with tiny meteoroids over ages so long they stretch beyond imagination. That endless bombardment has layered the surface like pages in a book. The topmost layer is constantly mixed by small impacts, turning over ancient material and exposing what lies beneath. Scientists call this slow churning process gardening. Through it, the moon's surface becomes a living archive. Though lifeless, it is always recording, always rearranging its history just enough to reveal its depth without erasing it. The craters themselves are monuments of memory. Some are as small as coins, while others stretch hundreds of kilometers across. The largest, the South Pole Aitken Basin, is one of the biggest impact sites in the solar system. It formed billions of years ago when a massive object struck the moon with unimaginable force. That scar still defines the moon's far side, a wound so ancient it predates most of Earth's visible crust. Each crater holds a snapshot of the moment it was made. The rims, the ejector patterns, the rays of bright material thrown outward all freeze the exact geometry of a cosmic event. By studying their depth and layering, scientists can determine the ages of surfaces, building a timeline of how often and how violently space has battered the moon. In this way, the moon becomes a cosmic calendar written not in ink, but in stone. Between these craters lie the lunar plains, smooth regions formed from ancient lava flows. When the moon was young, its interior was still molten, and great fissures allowed lava to flood across its face. As that lava cooled, it filled older impact basins, creating the dark maria that form the familiar patterns we see from Earth. These plains are younger than the highlands, and their surfaces reveal a quieter but equally telling part of the moon's story. The Maria show fewer craters, meaning they are geologically younger. Their smoothness marks a later period of lunar history, when the bombardment had slowed, and internal heat briefly revived the Moon's volcanic heart. By mapping these regions and counting craters, scientists can trace the rhythm of the solar system's violence when collisions were frequent, and when calm finally began to settle. The regolith also holds more subtle records, microscopic glass beads and particle imprints left by solar wind. Without an atmosphere to protect it, the Moon's surface is constantly bombarded by charged particles from the Sun. These particles embed themselves into the soil, creating a record of solar activity. Each grain of lunar dust holds in its chemistry the story of the Sun's moods over millions of years. When scientists studied these implanted particles, they realized they were holding something extraordinary, an unbroken history of solar radiation. By measuring isotopes trapped in the grains, they could trace how the Sun's energy had changed over time. The Moon had become not only a record of itself but a recorder of the entire solar system's environment, a silent observer watching the cosmos unfold. Even the color of the lunar surface tells a story. Lighter areas belong to the ancient highlands, while darker plains reveal basaltic flows from volcanic pasts. Over time, exposure to radiation causes the surface to mature, darkening and reddening the soil. This process, called space weathering, acts like the slow aging of skin. Every hue, every subtle tint, marks how long the ground has faced the endless stream of solar wind. Beneath the top layer lies older dust, compressed and untouched for millions of years. It holds remnants of ancient impacts, glass fragments from vanished lava flows, and perhaps traces of volatile elements like hydrogen from passing comets. The deeper scientists dig, the farther back they travel in time. Each centimeter of soil represents thousands of years of exposure, a layered archive of the Moon's environmental past. The Moon's poles hold some of its most remarkable records. In the deep, permanently shadowed craters, where sunlight never reaches, temperatures fall to extremes colder than Pluto's surface. There, volatile molecules such as water ice can remain frozen for billions of years. These icy deposits may preserve pristine material from early in solar system history, fragments of comets and asteroids that delivered water to planets like Earth. By studying that frozen record, scientists hope to learn how water traveled through space, how it reached the inner worlds, and how it may have helped spark life on Earth. The Moon, in its silence, could answer the oldest question of all: how life began in a universe of stone and fire. Its surface holds the evidence, waiting patiently under shadows that have not moved since the dawn of time. Some impacts have even revealed what lies beneath. When meteors strike, they excavate material from deep within the crust and scatter it across the surface. By analyzing this debris, researchers can peer into the Moon's interior without drilling. Each new crater is a natural excavation, a scientific gift from cosmic chance. It's as though the universe itself helps uncover its own history, one strike at a time. The far side of the Moon tells a different version of this tale. Unlike the near side, with its vast Maria, the far side is heavily cratered and rugged. It represents an older, less volcanic face, a region that never saw the same internal melting that reshaped the near side. Comparing the two hemispheres reveals how unevenly the Moon cooled, how its crust thickened, and how internal heat slowly faded over eons. From orbit, spacecraft have mapped these differences in extraordinary detail. High-resolution topographic maps show every crater, ridge, and depression, allowing scientists to reconstruct the Moon's geological evolution. Gravity measurements reveal mass concentrations, dense regions beneath the surface, remnants of ancient lava or impact melt. The Moon's quiet face hides deep structures, silent but telling. Every surface feature serves as both evidence and mystery. The bright rays from younger craters, for example, radiate across hundreds of kilometers, yet over millions of years, they fade under constant bombardment. By measuring their brightness, scientists can estimate ages and trace the slow erosion of time itself. It is as if the moon slowly dims its own memories, leaving only the faintest outlines for the future to discover. The moon's record also includes humanity's brief visit. The landing sites, the rovers, the flags, all of them form a tiny, modern layer in an ancient archive. Future explorers will find these artifacts just as pristine as the day they were left. They too have become part of the moon's geological memory, preserved beside the craters and dust, woven into the story of the universe's oldest witness. The surface's ability to remember extends beyond science. It touches something human. To know that a place exists where every footprint remains, where time stands still, is deeply humbling. It reminds us that while our world changes endlessly, there are corners of existence that hold on to everything, every impact, every step, every trace of touch. The moon is a monument to memory itself. Each probe and rover that has since visited adds new detail to this endless record. From orbiters that map mineral compositions to landers that scoop up soil, all have contributed to expanding the moon's diary. The data they collect intertwines with the Apollo samples, allowing scientists to read not just a few scattered pages, but nearly the whole chronicle of this quiet celestial companion. The moon's surface will continue to keep its record long after we are gone. The next wave of explorers will leave fresh marks, new instruments, and perhaps even habitats. Yet the older layers will remain untouched beneath them, sealed away like memories under new experiences. The moon will hold both the ancient past and the fragile present, without judgment, without change. And when future generations look up at that pale, glowing disk, they will see more than reflected sunlight. They will see an unbroken memory, a canvas that has carried the story of creation, violence, endurance, and human wonder. The moon's surface, scarred but serene, will continue to record all of it, grain by grain, keeping forever the whispers of time written upon its eternal face. For centuries, people believed the moon had no atmosphere at all, a place of complete vacuum, utterly silent and still. And though that belief was mostly true, it was not entirely so. The moon does have an atmosphere, but it is so faint, so fragile, that scientists often call it an exosphere, a whisper of air so thin that it would make even the emptiest desert on Earth seem dense. Yet in that whisper lies a quiet beauty, a delicate mystery that tells its own story about how the moon breathes in silence. This exosphere is made of only a handful of atoms drifting far apart, so far that they almost never collide. The moon's gravity is too weak to hold a thick blanket of air, and the sun's radiation constantly strips away what little there is. Still, a ghostly mix of gases hovers above its surface: helium, neon, hydrogen, argon, and even traces of sodium and potassium. They move like wanderers, floating above the dust before slipping away into space, like thoughts that never settle. Most of these atoms are born from the solar wind, the stream of charged particles flowing endlessly from the sun. When those particles strike the lunar soil, they knock loose atoms that drift upward, forming the faintest breath of atmosphere. Others come from micrometeorite impacts that vaporize small bits of rock, or from radioactive decay deep within the moon's crust. The result is a fragile balance, a slow exhalation of gases constantly replenished and constantly lost. To measure something so tenuous required extraordinary precision. When the Apollo 17 astronauts carried the Lunar Atmospheric Composition experiment, it recorded traces of these gases, confirming the moon's faint atmospheric whisper. For the first time, scientists had proof that the lunar environment was not entirely void. It was not air as we know it, it was a shimmering veil of atoms, too thin to feel, too faint to hear, but undeniably there. Argon, one of the key gases detected, comes from the radioactive decay of potassium within the moon's rocks. Its presence revealed that the moon is still quietly active, not volcanically, but geochemically. Even in its stillness, it releases a soft, steady breath from its ancient interior. It's as though the moon has not died completely, but lives in a state of eternal calm, exhaling its secrets in molecules instead of words. Helium and neon, on the other hand, are gifts from the solar wind. They are constantly replenished as sunlight streams across the surface, their atoms trapped in dust grains by day and released at night when the temperature plummets. Each sunrise and sunset on the moon reshapes this whisper-thin atmosphere, a delicate rhythm that marks time on a world without weather or air. It is the slowest breathing the cosmos could ever know. If one could stand on the moon without a helmet and somehow feel this exosphere, it would be imperceptible. There would be no wind, no pressure, not even the faintest hint of movement. Yet high above, sodium and potassium atoms glow faintly under sunlight, forming a ghostly haze that extends thousands of kilometers into space. This glow can even be seen from Earth with special instruments, a faint golden halo around the moon's edges, a silent shimmer against the dark. That glow, invisible to ordinary eyes, carries the memory of cosmic collisions. When meteoroids strike the surface, they vaporize traces of sodium and potassium, feeding the exosphere with short-lived bursts of light. For brief moments, the moon breathes a little more deeply, then slowly exhales those atoms into the void. It is a pulse of existence measured in faint glimmers rather than sound or motion, a cosmic sigh in the language of light. The exosphere also acts like a canvas upon which solar activity paints its moods. During solar storms, when charged particles flood space, the moon's thin gases respond. Argon levels rise and fall, sodium glows brighter, and the faint halo grows thicker for a time. Even without air or clouds, the moon feels the sun's energy, responding with its own delicate fluctuations, like the changing rhythm of a dreamer's breath. Despite its fragility, this atmosphere plays a quiet but crucial role in preserving information. Because it interacts directly with the solar wind and micrometeoroids, it helps scientists study processes that shape airless worlds. Each atom in the exosphere is a clue to how planets evolve, how radiation sculpts surfaces, and how atmospheres are born, lost, or transformed. The moon becomes a laboratory, its silence the perfect environment for cosmic listening. When night falls on the moon, the temperature drops to hundreds of degrees below zero. In that freezing darkness, atoms sink closer to the surface, some lodging temporarily in cold traps near the poles. When sunlight returns, they are released again, beginning another gentle migration. This daily cycle of capture and release is like the moon's heartbeat, so slow and faint that it takes instruments, not senses, to detect it. Unlike Earth's thick air, which carries sound and life, the moon's exosphere is purely a whisper of interaction. It cannot support a sound wave, it cannot carry a scent. Yet it reveals how matter behaves in near vacuum, how atoms drift between solid and space. Studying it helps scientists understand Mercury's faint exosphere, or the thin gases surrounding distant moons like Europa or Ganymede. The moon's silence becomes a guidebook for other worlds. The Apollo missions left behind their own marks on this whispering atmosphere. When rocket engines fired, they disturbed the local gases, adding short-lived plumes of exhaust that instruments recorded. These artificial traces showed how easily the exosphere can change, how sensitive it is to any new presence. Even human footsteps, stirring dust, may have briefly released trapped atoms back into the airless sky before they vanished. Again. Over time, robotic missions built upon these early findings. NASA's LADEE mission, launched in 2013, orbited the moon to study this exosphere in greater detail. It detected argon, helium, and even traces of neon, confirming that this thin veil is dynamic, shifting with day and night, sunlight and shadow. LADEE's data painted a portrait of an atmosphere that was not dead, but delicately alive, an invisible tide flowing across the surface. The discoveries also raised new questions. Could water molecules, too, be part of this faint atmosphere? Scientists began to find signs that trace amounts of hydroxyl molecules related to water might form on the surface during daylight, created when solar wind interacts with oxygen in the soil. If that breath connects it to every other world touched by sunlight. Even now, telescopes on Earth can detect changes in the moon's sodium glow, observing it like astronomers watch stars. Sometimes the glow strengthens after meteor showers, when countless tiny particles strike the surface, feeding the exosphere with fresh atoms. The moon reacts, not with thunder or light, but with a deepening of its invisible shimmer. It is a world that answers touch with radiance. The exosphere also preserves history. Some of the gases detected today may have been released by ancient volcanic activity, trapped and re-emitted over billions of years. In this way, the moon's atmosphere becomes a reservoir of memory, a mixture of present and past breaths. When we measure its composition, we are not just studying what the moon is, but what it has been, and what still lingers from its fiery youth. If one could listen somehow, not with ears, but with instruments fine enough to hear the movements of atoms, perhaps the moon's atmosphere would hum softly, like a vibration of distance and age. It would carry the rhythm of solar winds and cosmic dust, the soft drumming of meteoroids upon stone. Its voice would not be loud, but it would be constant, eternal, and profoundly patient. And in that patience lies understanding. The moon teaches that silence does not mean absence, it can mean balance, continuity, and awareness. Its exosphere, almost nothing, reveals almost everything, how delicate a world can be, how even the smallest exchanges between sunlight and rock can shape cosmic behavior. The moon, in its stillness, becomes the quiet teacher of motion itself. For future explorers, this atmosphere will be both obstacle and guide. It will remind them to tread gently, to measure carefully, to understand before changing. In its faint breath lies the blueprint of balance, a harmony between stillness and motion that humanity must learn if it is to live beyond Earth. The moon whispers it softly, every second, every orbit, for those patient enough to listen. And so, though the moon's atmosphere is the thinnest in the solar system, its story is among the richest. It tells of persistence and fragility, of endless exchange between dust and light. It is the echo of creation, still resonating in atomic form. And as long as it remains, that whisper will continue to remind the universe that even silence can have a voice, and even emptiness can breathe. After the footsteps had faded and the dust of Apollo settled into silence once again, humanity turned to a new kind of exploration, one that did not rely on the human presence but on the quiet eyes of machines. These were the orbiters, the map makers, the silent watchers that traced the moon's every ridge and hollow from above. They arrived not with footsteps but with light beams and sensors, their purpose not to touch but to see, to remember, to record. The moon, once a mystery seen only from afar, began to reveal its skin in exquisite detail. NASA's lunar orbiter missions of the 1960s had already laid the foundation, photographing potential landing sites for Apollo. But now, newer generations of orbiters would do more. They would paint a complete portrait of the moon, not in grainy black and white, but in maps of gravity, temperature, and even composition. The moon was no longer just a destination, it was becoming a living dataset. When the Clementine mission launched in 1994, it marked a turning point. A joint project between the Department of Defense and NASA, Clementine's purpose was both scientific and technical, to test sensors for future missions and to map the entire moon in multiple wavelengths of light. Over 70% of its data came from the far side, the hemisphere never seen from Earth. For the first time, humanity had a near-global image of the moon's hidden face. Those images showed something astonishing: vast basins, ancient craters, and subtle color differences that hinted at variations in mineral content. Clementine's data also suggested the presence of water ice near the lunar poles, locked in shadowed craters that never see sunlight. This possibility stirred imagination everywhere. If ice existed, then so did the potential for sustaining future explorers. The Moon, once seen as barren, began to seem quietly generous. Then came Lunar Prospector in 1998, a small spacecraft with a big purpose to confirm Clementine's hints. It carried instruments that could detect elements like hydrogen, iron, and uranium. When it orbited over the poles, it found strong signs of hydrogen concentrated in permanently shadowed regions. That hydrogen likely came from water ice, a discovery that transformed the way scientists viewed the Moon's potential. Even in its darkness, it carried life's most essential ingredient. Each mission refined the Moon's map. Its gravity field was charted, revealing invisible details about what lay beneath. Where the pull of gravity was stronger, scientists could infer buried structures, perhaps ancient lava tubes or dense rock masses left by meteorite impacts. The Moon's invisible layers were now being traced by mathematics, turning its quiet stillness into a landscape of numbers that spoke of age and history. The Japanese orbiter Selene, also called Kaguya, arrived in 2007 and continued the work with precision and grace. It carried a high-definition camera that captured breathtaking videos of Earth rising over the lunar horizon, a sight that filled millions with awe. But beyond beauty, Kaguya mapped the topography with unprecedented detail. It revealed that the Moon's crust was thicker on the far side than on the near side, suggesting a complex formation story still being unraveled. India, too, joined this quiet mapping of the Moon with Chandrayaan-1 in 2008. This orbiter carried instruments from multiple countries, including a NASA radar that made a groundbreaking discovery: strong evidence of water molecules on the surface, bound within the lunar soil. The Moon's story was changing again, from a dry relic to a world with hidden reservoirs of moisture, preserved through billions of years of solar bombardment. These orbiters did more than gather data. They built the foundation for understanding how to live beyond Earth. By mapping radiation, surface temperatures, and mineral compositions, they helped design the future missions that could mine oxygen from lunar rocks, harvest ice for drinking water, and even use local dust to build shelters. The Moon was becoming a partner, not just a subject of study. Then came NASA's Lunar Reconnaissance Orbiter, LRO, in 2009, perhaps the most detailed cartographer ever to circle the Moon. It carried 7 instruments designed to scan the surface in incredible resolution, down to the size of a small desk. Every crater, every slope, every boulder could now be seen in exquisite clarity. LRO even captured images of the Apollo landing sites, where the astronauts' footprints still linger, undisturbed by wind or time. Through LRO's eyes, scientists saw how the Moon changes, ever so slowly. Tiny new craters appeared over the years, evidence that meteorite impacts still reshape the surface. Thermal sensors mapped how quickly the ground cooled after lunar night, revealing patches of rock and dust that behaved differently. The Moon was not dead, it was evolving, subtly, endlessly. Its skin still responded to the universe's smallest touches. Other orbiters soon joined, from China, Europe, and beyond. China's Chang'e missions, beginning in 2007, combined orbiters, landers, and rovers into a long, careful campaign to understand the Moon's surface and geology. Their orbiters mapped minerals with remarkable accuracy, helping select landing sites for the later Chang'e 3 and Chang'e 4 missions. The latter made history by landing on the far side of the Moon, the side that had, until then, never felt a human-made touch. Each new mission carried the spirit of quiet curiosity. The Moon became a meeting ground for nations, a shared canvas where science transcended politics. The orbiters didn't compete, they complemented each other. Together, they built an intricate network of data, height maps, mineral charts, gravity grids that revealed the Moon as a dynamic, layered, and deeply ancient world. Its surface was no longer blank space but a story written in dust and shadow. The maps these orbiters produced were breathtaking in scope. They showed vast seas of basalt frozen from ancient volcanic floods, mountain ranges razed by cataclysmic impacts, and polar craters so deep that sunlight had never touched their floors. They revealed the scars of time, the outlines of events that shaped not only the Moon but also Earth itself. Each image was a page from the shared chronicle of the solar system. As instruments improved, scientists began mapping the Moon in invisible light, in infrared, ultraviolet, and radar. Each wavelength revealed something new. Infrared showed how heat moved across the surface. Ultraviolet revealed subtle traces of minerals. Radar pierced the shadows of craters to search for ice. With every pass, the Moon's story deepened. It was no longer just a rock, it was a mirror of cosmic evolution. The orbiters also served as historians. They documented where humans had once stood, where their spacecraft had landed, and where their machines still rested. Through their eyes, we saw the descent stages of Apollo, the long shadows of rovers, and the tiny marks of exploration left decades ago. These relics stood untouched, perfectly preserved in the Moon's stillness, a testament to the brief moment when humanity first reached beyond its world. Even as the orbiters circled in silence, they felt the Moon's pull. Its gravity tugged at their paths, creating subtle variations that scientists used to map the internal structure. NASA's Grail mission in 2011 used twin spacecraft to measure these tiny changes in distance, producing a map of gravitational strength that revealed the Moon's hidden bones, ancient basins, mass concentrations, and the remnants of old impacts buried beneath the surface. These maps showed that the Moon's crust was uneven, its density shifting with each basin and mountain. They told of a violent youth when molten seas cooled and impacts scarred the face we now see so calm. The Grail data hinted at how the Moon's far side might have formed differently, preserving thicker crust while the near side thinned beneath ancient lava flows. Every detail became a clue in the Moon's long, slow tale of creation. With so many eyes watching, the Moon was no longer mysterious but more intimate. Its craters gained names and context, its mountains became familiar. Scientists could trace the path of lunar rivers of molten rock that once flowed billions of years ago, frozen mid-motion like a captured breath. The orbiters turned the unknown into the known, and the Moon became not just a destination, but a neighbor we finally began to understand. Still, even as we mapped its every contour, something about the Moon's mystery remained. Its stillness, its soft light, its ancient scars, they held a kind of quiet majesty that maps could never erase. The orbiters could describe its features, but not its feeling. To know the Moon was to sense both its fragility and its endurance, a balance that data alone could not capture. The orbiters, patient and tireless, continued to circle, transmitting streams of information across the void. Their signals, faint but steady, crossed the 250,000 miles between worlds, whispering in code the secrets of an ancient companion. In their silence, they carried humanity's unending curiosity, our need to see, to measure, to understand. The Moon had become a mirror not just of sunlight, but of human wonder. Every photograph taken from orbit added another brushstroke to the cosmic painting. The Moon's far side, once imagined as alien and unknown, became a place of familiar craters and smooth plains. Even the smallest ridges were catalogued, their shadows traced by instruments that never slept. These orbiters were like dreamers circling in perpetual twilight, keeping watch while humanity rested. Through their lenses, we learned that even a barren world could hold layers of story. Beneath the silence lay motion, beneath the stillness lay change. Dust shifted, atoms danced, and ancient ice waited in frozen hollows. The Moon was not empty, it was simply quiet. The orbiters listened for what could not be seen, revealing the eloquence of stillness itself. And so the map makers continue their work, even now. New missions refine the details, update the old charts, and discover small but wondrous things: a new crater here, a landslide there, a patch of frost glittering in the dawn. Each discovery adds another note to the moon's song, a melody played in photons and gravity. The more we learn, the more the moon becomes both familiar and eternal. Perhaps that is the true gift of these orbiters, not just the data they send, but the perspective they grant. They remind us that exploration is not always about motion or conquest. Sometimes it is about watching, waiting, listening. The orbiters drift endlessly, eyes open in the night, and through them, the moon speaks softly back to us across the ages. And as long as they circle there, humming quietly in the void, the moon will never again be just a silver light in our sky. It will be a world alive with meaning, a companion mapped, understood, and cherished. The orbiters, the map makers, have given the moon its memory, its face, its story, and in doing so, they have helped humanity find a reflection of itself in the quietest place of all. In the eternal twilight of the moon's poles, there exist places where sunlight has never touched, craters so deep and old that their floors remain trapped in perpetual darkness. These are the moon's coldest places, colder even than the surface of distant Pluto. Temperatures there plunge to below -240 degrees Celsius, a chill so absolute that atoms barely move. For billions of years, these shadows have stood untouched, sealed away from warmth, keeping their secrets buried in the frozen stillness. When the first orbiters began mapping these polar regions, scientists noticed something strange: areas that reflected radar signals in unusual ways. At first, the reflections were mysterious, bouncing back with a brightness that didn't match bare rock. They could not be explained by dust or crater geometry alone. Slowly, suspicion grew. What if those bright echoes were the signatures of ice, ancient and unmelted, hidden within these craters where sunlight could never reach? The idea was extraordinary: water ice on the moon, preserved across eons. The Clementine mission hinted at it, and Lunar Prospector strengthened the evidence by detecting hydrogen, likely bound in frozen form. Yet confirmation required precision and patience. It was not enough to guess. Scientists wanted to see, to touch, to measure. So began the search, guided by radar, neutron spectrometers, and thermal cameras, tools designed to peer into shadow without light. As the data deepened, the picture became clearer. These permanently shadowed regions, or PSRs as scientists call them, act like cosmic freezers. Because the moon's axis tilts only slightly, the sun never rises high enough to shine into some crater bottoms near the poles. These shadows have endured for billions of years, preserving whatever fell into them, whether it was water brought by comets, hydrogen from the solar wind, or vapor from volcanic outgassing long ago. The Lunar Reconnaissance Orbiter's thermal mapper provided striking evidence. Its sensors found that some crater floors barely rose above 30 Kelvin, only a few dozen degrees above absolute zero. At such temperatures, ice could survive indefinitely. The moon, once thought too hot and airless to hold water, suddenly seemed to possess pockets of astonishing cold, tiny time capsules of the early solar system, frozen and untouched. Then came the deliberate impact of NASA's iCross mission in 2009, a bold experiment to test what lay within those shadows. The spacecraft's spent rocket stage was directed to crash into the floor of Cabeus crater near the lunar South Pole. As it struck, it released a plume of material high into the sunlight, and instruments aboard the trailing probe analyzed the debris. The results were stunning: clear signs of water ice mixed with dust, along with traces of methane, ammonia, and organic molecules. That plume was more than a moment of discovery, it was a glimpse into the ancient chemistry of the moon. The ice within those shadows was not pure, it was a blend of cosmic ingredients, frozen together in layers that had accumulated over ages. Each molecule might have arrived from a comet's tail or a solar wind particle, embedding its story in the frost. The moon, silent and still, had quietly gathered the ingredients for life, even if it never hosted it. The polar craters became laboratories of cosmic history. They preserved the record of impacts, of solar radiation, and of chemical interactions from the earliest days of the solar system. By studying their contents, scientists could learn not only about the Moon, but about Earth's own beginnings, how water and organics may have arrived from beyond, carried by icy wanderers across the dark void. These frozen places became windows into time. Some of these craters, like Shackleton near the South Pole, are particularly fascinating. Its rim catches sunlight almost all year, while its interior remains trapped in darkness. The rim could one day power solar panels for lunar bases, while the crater's floor might hold vast reserves of ice. The juxtaposition of eternal light and eternal shadow makes it a place of extraordinary potential, a symbol of balance between survival and stillness. Radar studies from Earth and orbit confirmed the likelihood of buried ice deposits, especially near the South Pole. Unlike the small frost patches found elsewhere, these seemed massive, possibly mixed with lunar soil in thick layers. If mined carefully, they could supply future astronauts with water for drinking, oxygen for breathing, and hydrogen for fuel. The Moon, it turned out, may already carry the resources needed for humanity's next frontier. Still, the ice does not lie openly. It is woven into the regolith, trapped in grains, or buried beneath a thin crust of dust. Some may even exist as vapor temporarily migrating across the surface, freezing again when night returns. The Moon's cold traps are not just still, they are dynamic in subtle, invisible ways. Molecules move slowly through this deep freeze, shifting between shadow and light in an endless, delicate cycle. As scientists began to understand these processes, they realized that the Moon is not static. Even in its silence, it breathes in a way, atoms and molecules rising, drifting, freezing again. Solar radiation can break water apart into hydrogen and oxygen, scattering them across the surface. Some escape into space, some settle once more in shadowed cold. It is a fragile equilibrium, maintained through billions of sunrises and lunar nights. To stand at the edge of such a crater, if one could, would be to look into eternity. The darkness below would be absolute, swallowing all light. No reflection, no shimmer, just depth. The cold would press outward like invisible stone, ancient and patient. Somewhere beneath that surface lies ice that predates human civilization, perhaps even predates the formation of Earth's oceans, a silent library of frozen memory, waiting to be read. When the Chandrayaan-1 mission confirmed traces of water molecules across the Moon's surface, it strengthened the idea that water is not rare but widespread, especially at the poles. Later missions refined this view, showing that the frost in some regions may appear and disappear with the rhythm of day and night, constantly being created and destroyed. Even in desolation, the Moon maintains a quiet pulse, a slow heartbeat of chemistry. The permanently shadowed regions, once invisible, are now being mapped in exquisite detail by orbiters using laser altimeters and infrared sensors. They reveal craters within craters, pockets of absolute darkness where sunlight has not fallen for billions of years. These regions hold the Moon's coldest secrets, frozen plains untouched by time, where cosmic dust still glitters faintly in reflected starlight. Scientists dream of sending robotic explorers into those depths, machines designed to withstand the freezing stillness and scoop up samples from the ancient frost. Such missions could uncover not just ice, but the timeline of impacts and solar events written into the layers. Each molecule of frozen gas could reveal how radiation, time, and cosmic debris have shaped the Moon's face. The shadows are not empty, they are archives of the solar wind. There's something poetic in the idea that the Moon's darkest places may also hold its most precious resources. In the regions where light never shines, there exists the potential for sustaining future explorers and the knowledge of the past. The cold preserves not only ice but truth, the unbroken chain of events stretching back to when the moon first cooled from molten rock. Its frozen silence holds a language older than words. The search for these icy pockets has also changed how we understand other worlds. Mercury, for instance, has similar polar craters where ice may also exist, despite its proximity to the Sun. By studying the Moon's cold traps, scientists learn how temperature, tilt, and time conspire to create havens of preservation even in the harshest environments. The Moon, in its simplicity, teaches the rules of survival for planets and moons alike. And as instruments improve, scientists are discovering that these cold traps are not limited to the poles. Smaller, temporary shadows in craters near the equator may also host microice deposits, forming and vanishing in tune with temperature swings. It's as though the Moon still plays with balance, hiding tiny flashes of frost in unlikely places, momentary reminders of how water wanders even in airless silence. For future explorers, the poles represent both challenge and promise. The darkness and cold will test machines and human endurance alike, yet the reward may be immense. Establishing a base near a permanently shadowed crater would allow access to sunlight and ice, to warmth and water. The Moon could become not just a stepping stone, but a sustainable home, a place where ancient frost fuels the dream of permanence. Yet even as we imagine mining those frozen reserves, scientists urge caution. These are not just resources, they are records. Each molecule has a story, a trace of a comet, a whisper from the solar wind. Disturbing them too hastily could erase information that no experiment could recreate. To explore the shadows is to balance curiosity with reverence, for the cold places are sacred in their stillness. When orbiters look down upon the poles, they capture the faintest gleams of reflected light along crater rims. These bright edges frame vast interiors of absolute blackness. The contrast is breathtaking, a boundary between eternity and existence, between warmth and unending frost. Within those silent depths, time has stopped. Every particle remains where it settled, undisturbed for longer than life has existed on Earth. The Moon's hidden cold places remind us that even silence can preserve creation. They hold not movement, but meaning, not energy, but endurance. In their shadows, we glimpse the persistence of the universe's earliest moments. And though no human has yet walked their floors, our machines' faint glances have already made them familiar, mysteries now half-known, half-dreamed. In years to come, landers will descend into these craters, their lights cutting through the black. They will drill gently into the frozen regolith, lifting grains of ice that may glisten faintly for the first time in billions of years. Perhaps, as those samples vaporize in the warmth of analysis, they will release the soft sigh of history, the breath of comets, the whispers of starlight caught and kept. Those cold, locked places will teach us humility. They remind us that even the smallest pockets of darkness can hold vast meaning, and that not all treasure glitters in sunlight. The Moon's shadows are not voids, they are guardians of time, keepers of purity, protectors of memory. And in their patient stillness, they speak of a truth the stars have always known, that light is precious only because of where it cannot go. So, while the rest of the Moon gleams in silver brightness, these polar craters remain forever hidden, forever silent. Yet it is in that silence that the greatest stories lie waiting, of water's journey, of creation's persistence, of the endurance of cold and calm. The Moon, once thought empty, holds its heart in these frozen hollows, where darkness keeps the past safe, and eternity quietly breathes. It might sound strange at first, to send something so far across the void, only to let it fall. But NASA's lunar missions taught humanity something profound. Sometimes, to listen deeply, you have to create an echo. The Moon, silent and ancient, held her secrets too tightly, and scientists realized that gentle observation wasn't enough. So, they decided to make a little noise, a deliberate impact, a soft cosmic knock on her ancient door, to hear how she would sing back. The first such attempt came during the Apollo era, when empty rocket stages were intentionally crashed onto the lunar surface after delivering astronauts safely home. Seismometers left behind by earlier Apollo crews waited patiently, embedded in the gray dust. When the impacts occurred, they sent waves rippling through the moon's crust. Those ripples, faint but clear, were recorded, the first true sound of the moon trembling. It was, in a way, like hearing her heartbeat for the very first time. To the astonishment of scientists, the moon rang in a way no one had predicted. When an impact struck Earth, the vibrations would fade within minutes. But the moon was different, its quakes echoed for hours. It was as though the entire world had become a slow, hollow bell, resonating endlessly through its cold, brittle crust. The lack of moisture, the rigidity of the rock, and the vacuum surrounding it all combined to make that sound linger in eerie stillness. From those seismic echoes, scientists began to map the moon's interior. The patterns revealed a crust thicker than expected, a mantle dense and layered, and perhaps even traces of a small core deep inside. Every crash became a probe, each vibration a line of data, helping humanity peel back the moon's surface like pages in a geological diary. The impacts, though violent in theory, were in practice delicate instruments of understanding. As technology advanced, new missions took the same idea even further. The Lunar Prospector, in 1999, was sent deliberately to crash into a shadowed crater near the South Pole. Its death dive wasn't destructive, it was purposeful. By measuring the resulting cloud of debris, scientists hoped to find water or ice hidden beneath the surface. For a brief moment, sunlight caught the faint plume rising from the crater, a tiny, ghostly sigh from the moon herself. That experiment hinted at water, but it wasn't until later missions that humanity truly confirmed it. In 2009, NASA's ICROSS mission took the concept to perfection. It involved 2 spacecraft, a spent Centaur rocket stage and a following probe equipped with sensors. The plan was elegant. The first would crash into a permanently shadowed crater, and the second, flying just behind, would fly through the debris, tasting, measuring, and transmitting every clue before meeting the same fate. When the Centaur struck the crater Cabeus, the explosion sent up a plume of dust and vapor nearly 10 kilometers high. For a moment, it was like a gray flower blossoming in darkness. The following probe dived through the plume, collecting every trace. The readings that came back were astonishing. Water, not just a trace, but enough to suggest that the moon's polar craters were ancient vaults of frozen history, untouched by sunlight for billions of years. Scientists described the moment as surreal. The data showed that within that plume were not only water molecules but also carbon compounds, ammonia, and traces of other volatile substances, ingredients that once helped build planets and life itself. It was as though the moon had quietly preserved the building blocks of existence, locking them in deep, eternal cold. Humanity had awakened something that had been sleeping for eons. The crash was not destruction, it was discovery through resonance. The moon's quiet nature required gentle provocation, and every impact, from Apollo's rocket stages to LCROSS's Centaur, was an act of curiosity disguised as chaos. Even the way the moon's dust scattered told scientists about particle size, cohesion, and the texture of ancient regolith. In every burst of light and soundless dust, new pages of her story unfolded. Through seismic listening and deliberate impacts, NASA learned that the moon's interior was far more complex than expected. Beneath the crust lay fractures that extended deep into the mantle. Some areas were surprisingly porous, others dense and solid. The data painted an image of a world scarred yet stable, a place that had withstood billions of years of bombardment and still stood in quiet dignity. Each deliberate crash was a message sent and an answer received. From those responses came models of how the moon cooled over time, how its crust thickened unevenly, and how ancient lava once flowed beneath its hardened surface. Even the way seismic waves bounced and slowed helped determine which regions were glassy, fractured, or filled with dust finer than talcum powder. There was a poetic irony to it, to use destruction as a form of listening, to send something to its end in the name of learning. Yet in those final impacts, there was grace. The spacecraft that had traveled hundreds of thousands of kilometers were not dying in vain. Their final act was to help humankind see the invisible, to turn silence into data, and data into wisdom. They were messengers giving their last whisper to science. Over time, scientists began to realize that each seismic thrum was like a word in a language the moon spoke softly. Some impacts made sharp, clean echoes, others produced long, drawn-out tones that faded slowly. Together, they formed a pattern, a musical map of density, depth, and structure. The moon's interior wasn't uniform, it was layered, cracked, ancient, a place where cosmic time had written its story in rock and void. And what they heard between those tremors was just as important as the sound itself. The long, slow decay of vibrations hinted at a world without air to carry sound, without oceans to muffle it, without life to interrupt. It was pure resonance, an unbroken conversation between impact and stillness. The moon, it seemed, was always listening, she simply needed a reason to reply. The Icros crash also inspired something new, a vision for how humanity might study other worlds. If a small, planned impact could reveal so much about a frozen crater, why not use the same method on asteroids, icy moons, or even Mars? Controlled collisions became a new form of exploration, turning death spirals into instruments of discovery. The lesson of the moon echoed outward, into the design of future missions. Those impacts also had emotional weight. Scientists who had worked for years on these spacecraft often described their final moments with reverence. Watching the last transmissions before impact was like listening to a song fade away, a blend of sadness and awe. They knew that what came next wasn't silence, but transformation. The spacecraft became part of the moon, their metals scattered across the dust they had once observed from afar. The echoes recorded by Apollo's seismometers still exist, stored in archives and studied anew with modern algorithms. Each waveform, each strange vibration, is revisited with better tools and deeper understanding. Even decades later, new findings emerge, signs of how the moon's core slowly solidified, or how certain regions might still shift slightly under tidal stress from Earth's pull. The data never stops giving. Through deliberate impact, humanity learned the rhythm of a lifeless world. It discovered how the moon's crust absorbs energy, how fractures spread, and how the planet holds its own kind of memory. In those tiny vibrations was the record of an entire world's endurance, a cosmic body that had faced endless collisions and still remained whole. Somewhere in that data, hidden beneath lines of frequency and amplitude, lies the quiet poetry of cosmic resilience. The moon had been struck billions of times before, by asteroids, by comets, by fragments of ancient planets, yet she remained intact. The human-made impacts were merely whispers compared to her long history, but they allowed humanity to finally listen consciously to what she'd always been saying. And perhaps, in a deeper sense, those impacts symbolized the human desire to connect. Even across the gulf of space, there is a need to touch, to reach out, to hear an answer. When the moon trembled beneath those small collisions, it was not just science that stirred, it was wonder itself, moving quietly through the fabric of knowledge. In the echoes that followed, there was no anger, no violence, only music. Low, slow vibrations carrying stories of density, gravity, and age. They hummed through the vacuum, inaudible but real, weaving a link between our living Earth and that silent companion who has watched us since the dawn of time. So, the next time someone gazes up at the moon and sees her calm, unbroken light, they might remember that beneath that serenity are faint traces of listening. That somewhere, long ago, Humanity knocked gently on her surface, and the moon, patient and ancient, answered back in waves that still drift through the silence of eternity. And in that echo, that delicate conversation born from impact and observation, lies a reminder that discovery is not always found in sight or speech, but in the resonance between what we ask and what the universe whispers in return. When the first Apollo samples came home, scientists believed the moon was utterly dry. Every analysis seemed to confirm it. No trace of liquid, no hint of dampness in the rocks. The moon, they thought, was a desert more complete than any found on Earth, stripped of air and water by its violent birth. But in science, certainty rarely lasts forever. As instruments grew more precise, as light and data were studied in new ways, a faint signature began to emerge, a quiet, persistent suggestion that water, in some form, had been there all along. It started with spectrometers aboard orbiters like Clementine and Lunar Prospector. They detected hydrogen near the poles, a chemical fingerprint that hinted at something volatile, something frozen. Yet the readings were uncertain. Hydrogen could come from many sources, including the solar wind. It wasn't proof, but it was enough to stir curiosity. The idea that water might cling to the moon's coldest shadows refused to fade, like a whisper from beneath the dust. As the data piled up, attention turned toward the moon's poles, regions where sunlight never reached, where craters lay in eternal night. These places, colder than even Pluto's surface, were perfect traps for ice. Any water molecule wandering there would never escape. Over billions of years, comets striking the surface and meteorites laced with volatile compounds could have delivered enough to form thin, hidden layers of frost, preserved in silence. The ICROSS mission finally brought clarity. When its impact sent a plume rising from the shadowed crater Cabeus, instruments recorded the unmistakable signatures of water vapor, ice crystals, and hydroxyl compounds. It was not illusion or contamination, it was real lunar water, ancient and pure. That discovery changed the narrative completely. The moon was no longer just dust and rock, it was a vessel of frozen time, holding traces of cosmic history in its darkest corners. Scientists realized that the water was not limited to those deep, dark craters. Orbiters like India's Chandrayaan-1, equipped with NASA's Moon Mineralogy Mapper, found evidence of hydroxyl, a molecule formed when hydrogen bonds with oxygen across the sunlit surface. Though transient and delicate, these molecules formed and dissipated daily, as if the moon itself breathed in faint molecular sighs when kissed by sunlight. The presence of these tiny amounts of water-related molecules was astonishing. They suggested that the moon was not entirely inert but engaged in a subtle exchange with space, absorbing hydrogen from the solar wind, binding it to oxygen in its minerals, and releasing it again when heated. The moon, once thought dead, now seemed to have a rhythm, a delicate, molecular heartbeat under its silent skin. Further missions deepened the mystery. NASA's Lunar Reconnaissance Orbiter and other instruments found that not only did water exist in polar regions, but the deposits were uneven, patchy, and layered as though built over time from countless cosmic deliveries. Each meteorite, each burst of solar wind, each ancient collision had contributed molecules, slowly weaving a fragile network of frost beneath the dust. What fascinated scientists most was the way this water behaved. It wasn't gathered into ponds or lakes, but locked inside grains of soil, trapped in the molecular structures of minerals. A single handful of lunar regolith might contain only a few hundred parts per million of water, invisible to the eye, yet measurable with the right instruments. It was as though the moon had hidden her tears deep within her bones, keeping them safe from the harshness of the void. That water was old, perhaps as ancient as the solar system itself. Some of it might have come from Cometary ice, fragments from beyond Neptune that struck the moon during the period known as the Late Heavy Bombardment.